Hey there. Welcome to Module 1 where we're diving into the world of Java programming. We'll start off by giving you an overview of what Java is all about, taking a trip down memory lane to explore its history and evolution. Next up, we'll show you how to set up your Java development environment so you can start coding like a pro. And don't worry, we'll cover the basics of Java syntax to get you started on the right foot. So get ready to expand your programming skills and unlock the potential of Java. Let's jump right in and explore the ins and outs of this popular language. Alright, let's talk about Java programming language. So, Java is like the Swiss Army knife of programming languages. It's super versatile and can work on pretty much any device. Back in the 90s, Sun Microsystems came up with Java, and they made it so that code written in Java can run on any device with a Java virtual machine. This means that if you write an app in Java, it can run on any operating system. Pretty cool, right? Another neat thing about Java is its object-oriented programming features. Basically, this allows developers to create code that's easy to reuse and maintain. So, if you need to build an app that needs to work on different systems and you want code that's easy to manage, Java is a great choice. Hey there. Let's dive into the fascinating history and evolution of Java. So, back in the early 1990s, Sun Microsystems came up with Java as a programming language mainly for consumer electronics. Fast forward to today, and Java has become one of the most widely used programming languages globally. It boasts a huge community of developers and a vast array of libraries and frameworks. And get this, Java has played a crucial role in shaping the internet as we know it. It's the go-to language for building all sorts of things like web applications, mobile apps, and enterprise software. Pretty cool, right? So next time you're browsing the web or using an app, remember that Java is likely working behind the scenes, making it all possible. Cool stuff. Alright, so you're ready to dive into the world of Java coding. But first things first, you need to set up your Java development environment on your computer. This basically means getting the Java Development Kit, JDK, all sorted out, which includes important tools like the Java compiler and the Java Virtual Machine, JVM. But wait, there's more. You'll also need a text editor or an integrated development environment, IDE, like Eclipse or IntelliJ IDEA to actually write and run your Java code. These tools are super handy for any aspiring Java developer because they give you everything you need to create and test your Java applications. So, make sure you've got your JDK installed, pick your favorite IDE, and you'll be all set to start coding away in Java. Alright, let's dive into the basics of Java syntax. So, Java syntax basically lays down the rules for how we write and structure our Java code. This includes stuff like variables, data types, operators, control structures, like if statements and loops, and methods. The cool thing about Java syntax is that it's designed to be super easy to read and understand. This makes it accessible to programmers of all levels, whether you're a beginner or a seasoned pro. By sticking to the correct syntax, you can make sure that your Java code is free of errors and runs smoothly. So, remember to follow the rules and you'll be coding like a pro in no time. Hey there. Let's dive into a quick example in Java where we'll be adding two numbers together. So, we have a class called addNumbers. Inside our main method, we're declaring two variables, number1 and number2, with values 5 and 10. Then, we add them together and store the result in a variable called sum. Finally, we print out the sum of number 1 and number 2. Super simple, right? Just a neat little way to showcase how we can perform basic arithmetic operations in Java. Cool, huh? Alright, so in Module 2, we're diving into the basics of Java. We'll be covering some key topics that are essential to understanding how Java works. First up, we'll talk about variables and data types. These are basically the building blocks of any Java program. Then, we'll move on to operators and expressions, which are used to perform different operations on our variables. Next, we'll explore control flow, which includes if-else statements and loops. This is where we start to control the flow of our program based on certain conditions. And finally, we'll discuss methods and functions, which are like reusable blocks of code that perform specific tasks. So, by the end of this module, you'll have a solid understanding of the Java basics that will set you up for success in your programming journey. Let's dive in. Alright, so let's talk about variables and data types in Java. Think of variables as containers that hold data in your program. When you declare a variable, you need to specify its data type, like int for integers, double for floating point numbers, and string for text. By specifying the data type, you're helping the compiler allocate the right amount of memory for that variable. So, for example, when you write int my_number equals 5, you're assigning the value 5 to the variable my_number. And here's the cool part, you can update the value of a variable whenever you need to. Just use the assignment operator, smiley face, to assign a new value. This flexibility allows your program to adapt and change as it runs. So remember, variables are like little storage containers that hold different types of data in your Java program. Alright, so let's talk about operators and expressions in Java. Operators are those handy symbols that help us carry out operations on variables and values. We've got arithmetic operators like plus, minus, multiply, and divide, comparison operators for checking values, and logical operators for those Boolean expressions. Expressions are like little math puzzles we create using variables, values, and operators. For example, if we have x equals 5 plus 3, we're basically adding 5 and 3 together to get 8, and then storing that result in the variable x. It's like solving a mini equation in our code. So, just remember, operators are our helpers for doing all sorts of cool stuff in Java, and expressions are the magic combinations that make it happen. Cool, right? Alright, so let's talk about control flow in programming. Control flow statements basically determine the order in which instructions are carried out in a program. One common control flow statement is the if-else statement, which lets you make decisions based on certain conditions. So, if a condition is true, the code inside the if block gets executed, and if it's false, then the code inside the else block runs instead. Now, let's move on to loops. Loops are super handy because they allow you to repeat a block of code multiple times. In Java, you have different types of loops to choose from, like the for loop, while loop, and do while loop. For example, you can use a for loop to go through each element in an array and do a specific task for each one. So, to sum it up, control flow statements help you make decisions in your code, and loops help you repeat tasks efficiently. It's all about organizing the flow of your program to get things done the way you want them to. Alright, so let's talk about methods and functions. Basically, methods are like little blocks of code that do specific tasks. They have a return type, a name, and can have some optional parameters. Now, functions are a type of method that actually give you back a value. In Java, you can make your own methods to keep your code neat and organized. For example, let's say you want a method to calculate the area of a circle. You could define it like this: double calculate area, double radius, return math.py *radius *radius. This method takes the radius as a parameter and gives you back the calculated area. Cool, right? It's a great way to break down your code into smaller, more manageable pieces. Alright, welcome to Module 3, where we'll dive into object-oriented programming in Java. Today, we'll be covering some key topics that will help you understand the fundamentals of OOP. First up, we have classes and objects. Think of classes as blueprints for objects, which are instances of those classes. It's like designing a car, class, and then actually building one, object. Next, we'll talk about inheritance and polymorphism. Inheritance allows a class to inherit properties and behaviors from another class, while polymorphism enables objects to be treated as instances of their parent class. Moving on to encapsulation and abstraction. Encapsulation is all about bundling data and methods together within a class, while abstraction focuses on hiding implementation details and only showing the essential features of an object. Lastly, we'll touch on constructors and destructors. Constructors are special methods used to initialize objects, while destructors are used to clean up resources before an object is destroyed. By understanding these concepts, you'll be well on your way to mastering object-oriented programming in Java. So let's dive in and explore the exciting world of OOP together. Alright, so in Java, a class is basically like a blueprint for making objects. It lays out all the characteristics and actions that objects of that class will have. And speaking of objects, they're like specific examples of those blueprints in action. So, let's say we have a class named car. We can make different car objects, each with their own unique features like color, model, and speed. These objects can chat with each other by using each other's methods or checking out each other's details. This way, we can write code that's super organized and can be reused over and over again. So, you only have to create a class once, and then you can use it multiple times throughout your program. Cool, right? Alright, so let's talk about inheritance and polymorphism in programming. So, inheritance is basically when one class can inherit properties and behaviors from another class. The class that's doing the inheriting is called the child class, while the one being inherited from is the parent class. This whole setup allows us to reuse code and create a nice hierarchy of classes. Now, polymorphism is a bit different. It's when objects from different classes can be treated as if they're all part of the same superclass. This means that a method can act differently depending on which object is using it, giving us some flexibility in our programming. So, inheritance and polymorphism are really handy tools for building efficient and dynamic code. So, let's chat about encapsulation and abstraction in programming. Encapsulation is like keeping your data locked up in a class, only letting it out through certain methods. It's a way to protect your data and control how it's used. On the flip side, abstraction is all about hiding the nitty-gritty details and only showing the important stuff. This makes complicated systems simpler and easier to work with. So, think of encapsulation as your data's bodyguard, and abstraction as its personal stylist, making sure it looks good without revealing too much. Cool, right? Hey there. So, let's talk about constructors and destructors in Java. A constructor is basically a special method that gets called when you create an object of a class. Its job is to set things up and get the object ready to go. You can give parameters to a constructor to initialize values, and it always has the same name as the class. Now, onto destructors. In Java, we don't really have explicit destructors like in some other languages. Instead, Java has a garbage collector that takes care of cleaning up memory for us. But, it's important to remember to explicitly close any resources like file handles or database connections to avoid memory leaks. So, constructors get things started, and destructors clean up after us in Java. Just keep those resources in check, and you're good to go. Alright, let's dive into Module 4, where we'll be exploring the Java Collections framework. First up, we'll be looking at arrays and ArrayList. These are essential data structures in Java that allow us to store and manipulate collections of items. Next, we'll move on to linked list and hash map. Linked lists are great for maintaining an ordered sequence of elements, while hash maps are perfect for storing key-value pairs. Then, we'll discuss set and queue. Sets are useful for storing unique elements, while queues follow the first-in first-out (FIFO) principle for data retrieval. Lastly, we'll touch on iterators and sorting algorithms. Iterators help us traverse through collections, while sorting algorithms allow us to organize our data efficiently. So, buckle up and get ready to explore the Java Collections framework with us in Module 4. So, let's talk about arrays and array lists in Java. These bad boys are like storage units for holding a bunch of values of the same type. Arrays are like those fixed size boxes that you gotta know the size of from the get-go. But array lists? They're like those expandable bags that can grow or shrink as you need. When it comes to accessing stuff, arrays use indexes that start at 0. So, if you want to grab something from an array, you gotta know its place. But with array lists, they've got handy methods for adding, removing, and getting elements without all that index jazz. So basically, arrays are like a strict supervisor while array lists are more laid back and flexible. Gotta love that Java versatility, am I right? So, in Java programming, linked lists and hash maps are pretty common data structures that you'll come across. Let's start with linked lists. Think of it as a bunch of elements that are all linked together. This linking allows for easy adding and removing of elements in the middle of the list, which is super handy. Now, let's chat about hash maps. These are like a cool club where each member, or key, has a unique entry pass. And when you want to find a specific member, you can do so quickly because of this unique pass. Hash maps use a technique called hashing to make searching for and storing elements really efficient. So, linked lists and hash maps are both great tools to have in your Java programming arsenal. They make organizing and retrieving data a breeze. Alright, so now let's talk about sets and queues in Java. Sets are pretty cool because they don't allow any duplicate elements, so you can keep a nice, unique collection of items. On the other hand, queues are all about the first-in first-out rule, where elements get added at the end and removed from the front. This makes them perfect for things like task scheduling or passing messages around. So, sets and queues both have their own special functions in Java that can really come in handy for different tasks. Alright, so let's talk about iterators and sorting algorithms in Java collections. Iterators are basically like your tour guides through a collection of elements. They help you go through each element one by one using methods like hasNext, and next. Now, sorting algorithms are like the organizers of a party. They arrange the elements in a specific order, whether it's from smallest to largest or vice versa. You've got options like bubble sort or quick sort to get your elements in line. So, iterators help you navigate through your collection, while sorting algorithms help you organize it. Both are super important concepts in Java collections that you'll definitely want to get familiar with. Hey there. Welcome to Module 5 where we'll be diving into exception handling and file I/O in Java. So, first up, let's chat about handling exceptions in Java. When your code encounters an error, you can use try-catch finally blocks to gracefully handle those exceptions. It's like having a safety net to catch any issues that may pop up during execution. Next, we'll explore reading and writing files in Java. This is a super handy skill to have because it allows you to interact with external files and data. You can use streams to read and write information, and even delve into serialization to save and load objects. Overall, Mastering exception handling and file I/O in Java will level up your programming game and give you more tools to work with. So, let's jump in and start exploring these topics in more detail. Happy coding! Alright, so let's talk about handling exceptions in Java. Basically, exceptions are like those unexpected errors that pop up while your program is running, causing a bit of chaos. But don't worry, Java's got a solution for that. Enter try catch finally blocks. In the try block, you put the code that might cause an exception. And if an exception does happen, the catch block swoops in to handle it like a pro. Now, here's the cool part, the finally block is like the cherry on top, where you can add code that always runs, no matter what. This whole setup helps keep your program stable and reliable by dealing with errors in a smooth and graceful way. So, remember to use try, catch, and finally to keep your Java programs in tip-top shape. So, imagine you're trying to divide 10 by 0 in your code. Well, that's a big no-no in programming because it will throw an arithmetic exception. But hey, no need to panic. You can catch that exception using a try-catch block. Inside the catch block, you can display an error message to let the user know what went wrong. And guess what? The finally block is like the superhero of code, it always runs, whether there was an exception or not. So, remember to handle those exceptions and keep your code running smoothly. Alright, so when it comes to reading and writing files in Java, we're basically talking about working with data that's stored outside of our Java program, like in files on our computer. To do this, we use classes like FileReader, FileWriter, BufferedReader, and BufferedWriter. When we're reading files, we start by opening the file, then we read the data inside it, and finally we close it when we're done. On the other hand, when we're writing files, we create a new file, write data to it, and then close it once we're finished. This whole process is super handy for things like reading configuration files, grabbing data from external sources, or even saving important application data for later use. So, being able to read and write files in Java is definitely a useful skill to have in your programming toolkit. So, let's talk about reading a file in Java. Basically, you can use a buffered reader to help with that. You start by creating this buffered reader and giving it a file reader object that points to the file you want to read. In this case, let's say it's called input.txt. Then, you can start reading the file line by line. You do this by using a while loop that keeps going until there are no more lines left to read. Each time you read a line, you can do something with it. In this example, we're just printing it out to the console. But, it's important to handle any potential errors that might come up while reading the file. That's why we have this try-catch block here. If there's an issue with reading the file, an I/O exception will be thrown, and we can catch it and print out an error message. And that's pretty much it. Just a simple way to read a file in Java.
If you like this video, please like, share, and subscribe to the channel. Until next time.